What if I told you that a machine smaller than a car can generate enough power to push a multi-ton aircraft across the sky at near supersonic speeds? This machine can burn thousands of liters of fuel per hour, spin faster than a Formula One engine, and heat air hotter than lava all in seconds. Yet somehow, it doesn't melt. Today, we're diving deep into one of the most incredible inventions in modern engineering, the jet engine. If you're fascinated by cutting-edge engineering and the science behind powerful machines, make sure to hit that subscribe button and smash the like button. It really helps the channel grow and keeps content like this coming. Let's get started. What is a jet engine? A jet engine is a machine that creates thrust by throwing air backward. That's it. Air goes in. Fuel burns. Hot gases shoot out. The reaction pushes the aircraft forward. Jet engines spin at astonishing speeds. Low pressure spool, 3,000 to 10,000 RPM. High pressure spool, up to 20,000 revolutions per minute or more. That's faster than most race car engines and under far greater stress. Main parts of a jet engine. Inlet, air enters. Compressor, air gets squeezed. Combustion chamber, fuel burns. Turbine, extracts energy. Nozzle, accelerates exhaust. Afterburner, optional, extra thrust boost. Each part works in perfect sync. No room for error. The exhaust gases exiting the nozzle are extremely hot. Typical exhaust temperature, 500 degrees Celsius to 900 degrees Celsius. With afterburner, can exceed 1,800 degrees Celsius. How does a jet engine work? Think of it as a straight pipeline of power. Compressor. Air enters. Blades squeeze it tightly. Pressure rises fast. Combustion chamber. Fuel is injected. Ignition happens. Now you have extremely hot, high-energy gas. Rear turbines. Hot gases spin turbines. These turbines power the compressor at the front. Exhaust and afterburner. Gas shoots out at high speed. Thrust is created. If there's an afterburner, extra fuel is added here for a massive power boost. Simple flow. Compress, burn, spin, blast. What happens to air inside? Outside air. Air have normal pressure and normal temperature. But inside the engine, in the compressor, pressure jumps up to 30 or 40x. Temperature rises sharply. In combustion, temperatures explode past 1,500 degrees Celsius. At the exit, gas expands, shoots out at extreme speed. The air goes from calm to violent in milliseconds. Turbojet engines don't use ordinary fuel. They run on aviation kerosene, commonly known as Jet A or Jet A1. Why this fuel? High energy density. Stable at high temperatures. Safer than gasoline. Inside the engine, fuel is sprayed as a fine mist, mixed with highly compressed air, ignited continuously. This creates a constant stream of hot, high-pressure gas. How fast can a turbojet go? Typical speeds. Subsonic aircraft, 800 to 1,000 kilometers per hour. High-speed jets, 1,500 to 2,200 kilometers per hour. With afterburner, can exceed Mach 2. That's over 2,400 kilometers per hour. What is afterburner? This technology is insane. Afterburner equals extra power on demand. Used in fighter jets. It dumps fuel into the exhaust and ignites it again. Result? Huge flame. Massive thrust. Insane acceleration. But it comes at a cost. How does afterburner work? Normally, fuel burns in the combustion chamber. But not all oxygen is used. Afterburner takes advantage of that leftover oxygen. Inject fuel into exhaust. Ignite it again. Explosion continues behind the engine. This can boost thrust by up to 50% or more. It's basically turning the exhaust into a second engine. If the afterburner is left on, you can deplete your fuel in an instant. For this reason, it is not used continuously. It is employed only under extreme circumstances, such as evading an enemy missile or aircraft, or during takeoff from an airfield. The nozzle is where everything comes together. It converts thermal energy into kinetic energy, accelerates gases to extremely high speeds, produces the thrust that moves the aircraft forward. In advanced engines, the nozzle can even change shape to optimize performance. Jet engines are controlled explosions. Perfectly engineered chaos. And yet, they carry us safely across the sky. If you enjoyed this breakdown, like the video, subscribe to channel, and turn on notifications. More powerful tech videos are coming. See you in the next videos.